Here is a setup that uses EXOSTIV and an Artix-7 FPGA board with 3 times a transceiver at 5 gigabit per second to stream trace data out of the FPGA. In this demonstration, we will observe 2 data sources generated from inside the FPGA, a digital sine wave and a digital video source. These data sources are sampled with what we call capture units and sent over to the EXOSTIV probe with the FPGA transceivers. Please note that the first capture unit has got a 1K memory buffer and the second capture unit a 2K memory buffer. Here is EXOSTIV Dashboard Analyzer interface. As you can see, we have many controls to extract data out of the FPGA. I'm going to select the first capture unit and the sine wave data group, and I will start to collect exactly 1K samples from the FPGA. So 1K samples lets you visualize the quantity of data that can be stored inside the FPGA for debugging. In other words, this shows the amount of data that you would see with a JTAG-based logic analyzer that has got the same footprint on the FPGA resources. Now, let's switch back to the interface and let's capture much more data, which EXOSTIV allows you to do. So I'm collecting one capture of, let's say, 4,000, 40,000, 4 million samples. So here we will be collecting not 1,000 but 4 million samples as you can see here. So let's start. So this is the time taken for encoding the waves, but here you have a capture of 4 million samples. If I zoom in a little bit, you see that we have that sine wave repeating pattern. And if I zoom enough, yes, you see, we have multiple times the same sine wave periods. As you could see in the previous capture, 1K samples was exactly tuned to one period of the sine wave. This is to ease the reading and the comparison. Whereas with EXOSTIV, you can capture much more data. And if you zoom out, and for instance, if you are looking for a random bug, well, then you are able to find it. That glitch is a random bug that we introduced on purpose in the stream with no idea about when it would occur, but with a large observation window, then we are sure to capture it. We will be looking for another one because this is a repeating random bug. Let's have a look. As you can see, we can scroll the waves from the waveform viewer, and here it is very visual. Yes, I can find another random bug from my data stream. I am now selecting the video capture unit to show an interrupted capture. You can see from this first short capture that this video interface includes a start of frame signal, vertical and horizontal blanking signals, a line counter, and the red, green, and blue components, actually 10 bits values represented as analog waves. Say that we would like to observe what happens on this interface at the beginning of each frame. The first step to do this is to define a triggering condition to start a capture when there is a pulse on the start of frame signal, now in yellow in the waveform window. So let's add this signal start of frame in the sensitivity list of the trigger, and let's define a rising edge condition for this signal in the trigger window. I am now defining the number of times I would like to capture data. Let's capture data for the next 650 triggers, or in other words, the next 650 frames. And for each frame, I'm going to capture a little more than 26,000 samples with a trigger positioned after 19,000 samples in each capture. Okay, let's start. EXOSTIV is capturing data from the FPGA as I speak. You can see the number of captured frames on this progress bar and the elapsed time on the timer overlay. So now the captured data spans over 11 seconds. On the waveform display, we can see that we have indeed 650 captures. If we zoom in, we can see that the background color changes from black to gray and back for each capture, and that the red dotted lines are the triggers. They are numbered. If we zoom more, we can see that the trigger is indeed on the rising edge of the starter frame. Now, if we zoom out, we can check that we have positioned the trigger with 19,000 samples before it. Yes, as you can see on the scale above, this is indeed the number that we have specified for the pre-triggering. If we check the end of each capture, we should find about 7,000 samples after the trigger, because the total is 26,000 with 19,000 before the trigger. Finally, we can check that we have indeed collected 650 triggers. They are numbered from 0 to 649. Now we are going to use data qualification. Data qualification or data filtering allows you to specify a logic condition on the sampled data to filter what you capture. As you can see from the waveform window, we have a line counter in our data. Say that we are interested in a specific line of each frame of the video stream only. Well, by using data qualification, we can add a filter in EXOSTIV IP so that we discard any data that does not belong to that specific line. We have now added the line counter in the trigger sensitivity lists, and we have specified the line number as a qualification condition. Now let's run the capture again until the end. Yes, that's it. Wave encoding, and there are the results. We can see from the waveforms that only line 68 was captured. Actually, the waveform window displays the line counter as a decimal number, whereas the qualification condition was provided in hexadecimal. So if I switch the conditions radix to decimal, I can see that it is indeed 68 in decimal. Now if I specify 44 in decimal and run it again, let's wait until the end. Yes, you can see in the result that we have only captured line 44 decimal. We've reached the end of this presentation. Thank you very much for watching. Bye-bye now.